Welcome back, students. Let's take a look at this lesson, data structures in R. The objective is that students will become familiar with common data structures in R, the R programming language, right? So let's talk about those data structures. In a previous video, we looked at primitive data types, integers, numeric, which are like floats or doubles in other languages, characters, which are like strings in other languages, and logical, which they call it logical in R, which is like Boolean values. Now we're going to look at data structures that hold many of those type of values. The vector is a single dimension collection of values of the same data type, meaning they're all numeric, or they're all character, etc. Single dimension just means that there's just one dimension, like one thing. Whereas a data frame, which we'll see in a second, is a two-dimensional thing. It's got columns and rows, whereas the vector here is just simply one-dimensional, just a list of things. And it's kind of like a list in Python, if you know Python, or an array in Julia. Okay. And the values of different data types are coursed into the more complex data type. For example, if you have a numeric or a float and an integer, and then you put those into the same vector, both values will become the numeric, which is the more complex data type. Good, you can create it with the C function, and it's combine. Here's some documentation we can look at real quick together. Combine values into a vector or list. It's the very simple function, C. So let's take a look at their examples here. Right, we can just do our own example, right? Let's just jump over to RStudio to be exact. And down at the bottom part of my screen, I don't even need any of this stuff. Let me just shut down this project. That was for a different thing. Down at the bottom part of my screen, right, if I create a vector, let's call it fruits, plural, and I do the assignment operator. In this case, I'll do that R specific one, C, and I have an apple, comma, banana, orange, mango, etc. You can see in the top right of my screen, I now have this value called fruits. And if I were to type fruits at the console down at the bottom left of my screen, push enter on my keyboard, I see the 4 elements in that vector. Like I mentioned a second ago, if I were to put 2 different data types into one vector, the less complex data structure, data type would be forced or coerced into the more complex one. So I'll just say X, assignment operator. If I can get the assignment operator correctly, there it is. C, if I were to say 5L for integer and 3.14159, you can see on the top right, it's saying these are numerics. And if I were to ask class, what is the data type of the elements? It says numeric. So it actually coerced this 5L, which is an integer, into a numeric, which is a float as a decimal point. Okay, cool. Let's go back here. The data frame is a tabular data set. Tabular is an adjective form of table, right? A tabular data structure with columns and rows, much like a table in a spreadsheet software like Excel or Google Sheets. So let's take a quick look here. Let's just jump right down to the examples they have in the documentation. So here's a simple data frame. We can just grab their example, Control C that, or Command C that if you're on Mac, right? Okay. So anyway, we have a data frame that has 10 rows and 3 columns. This column here, that column there, and this column there. These are not well-named columns, but anyway, there are 3 columns by 10 rows. That is a 2-dimensional data structure, meaning we have left to right dimension and we have up-down dimension, columns and rows. And this is the data structure we'll probably spend most of our time with in this class. Okay, a Tibble, this third one there, is simply a souped up or improved data frame. And it's part of the tidyverse meta package or ecosystem. Okay, it simply has some nice features that improve upon the data.frame data structure, which is part of base R. The data.frame, again, data structure is part of base R, whereas the Tibble is part of the tidyverse meta package or ecosystem. And it's simply another type of data structure. It is a data frame. It just simply has some improvements. The data.table is another tabular data set. It's written in C under the hood, and therefore it's fast. And it is somewhat of a competitor to the Tibble data structure. And the whole data.table package is somewhat a competitor to the tidyverse meta package. They're not really competing necessarily, but maybe they are in some sense. Anyway, you can take a look here. Here is their CRAN page. CRAN stands for Comprehensive R Archive Network. Anyway, it can deal with large data sets, and it's super fast. It's faster than Tibble's because it's written in C. A lot of authors. The main author, if I'm not mistaken, is Dirk. I don't see him in here. Quickly, I assume he's in here somewhere. But anyway, that is DataFrame. I don't think I'll ever show it to you guys. I'll rely on the tidyverse ecosystem in their Tibble. A matrix is a base R data structure, which again is tabular, meaning it has rows and columns. And it's less common, at least for our purposes, than data frames, whether the Tibble data frame or the base R data frame. And it has its place. Sometimes some functions only take matrices, and you have to convert your data frame into a matrix in order to run it in the function. But again, it's simply a data frame. It's a data type that is tabular in nature. We can take a look here. If I just grab a little bit of code, Command C that, come back over here into my console, Command V that. There you go. So we have 2 rows and 3 columns in this little matrix. That's a matrix. You can create one with the matrix object there. Okay, the list is a super flexible data structure that can hold pretty much anything, including other data structures. So let's take a look at their documentation. There's that. Let's jump down to the examples right away. Let me see if I can grab, I guess I'll just grab this little bit of code and see if this works for us here. I wonder if I need to import cars on this. Let's take a look. If I just let that go, what does that do? PT. Okay, that worked. Okay, so what we have here is we have a list. You can use the list function to create a list. This is an R list, not to be confused with the Python list. This is an R list, which is different. If you know Python, don't let it confuse you. What we have here is we have 2 elements in this list. We have X and Y, and then within X we have a vector. So the first element of the list is a vector, and the second element of that list is also another vector. And if I wanted to, I could probably add a third vector. If I go this and say whatever, I'll call it third thing, and I want to say I want you to have, I don't know, I'll just say hello world. How about that? And then I look at PTS again. You can see it added a third element to that list, and that third element is a single element character vector, to be quite exact what that is. That's a single element character vector. And these are integer vectors, looks like to me. This integer vector up here. So anyway, a list is super flexible. So it can hold pretty much anything in R, including other data structures, including simple values. Like, for example, if I were to add another thing, let's add a 4th thing. I'll just call this 4th, and I'll say I want this to be 3.1415926, and then I look at PTS. Now it's got a floating point or a numeric number in there as the 4th thing. So it can hold single values, it can hold vectors, it can hold other lists even. So anyway, it's super flexible data structure. We won't see these a whole lot. The majority of our time will be spent with data frames, and specifically the Tibble version of the data frame. That is kind of the one that's most often used in the tidyverse meta package ecosystem. So your activity here is to create some of these data structures. Looking at their documentation, you can come up into my lesson plan here. I'll link to in the description of this video. You can click on the links I have in here to look at the documentation for these various data structures. You're just going to create these data structures. So create a few vectors of the same length. Great. Then create a simple data frame with several vectors created from above. Okay. Then create several data frames and put them into a list. Students iterate over the list in a for loop and print each data frame in the console to the console. Students iterate over the list and then iterate over the row of each data frame and print each row. So go ahead and pause the video now and give it a try. Ready, set, pause it. Welcome back. Let's take a look. Students create several vectors of the same length. Let's try that. How would we do that? Down on the console, it might be best to use this file now. Let me just come up here and use a file. Let me create, I'll say person, assignment operator C, right? Let me zoom in. Probably see that. Let me zoom in. Let's say Bobby and Luisa and Luke, 3 people. Let's say age. If we know their ages, we can put them in here. Let's say Bobby's 23, Luisa's 34, and Luke is 45. Whatever. Let's say location there. Let's make this using the C function. Let's say one's in Provo, one's in Rancho Cucamonga. Name that state. It's California where I grew up. And then we can say Manhattan. Kansas, obviously not New York. Manhattan, Kansas is where it's at. Small Apple. The Little Apple, that is. I was lived there for 5 years. Anyway, so we have 3 vectors we created there. Boom, boom, boom. Run those lines. Copies it down to the console. Right, there we go. That's how you create some vectors. Next one, create a single data frame with the several vectors created above. If you want, you can look at this documentation, which shows you how you could do that. I will show you how to do that, but you can add in the vectors right there. So let's do that. Let's say data.frame. We're going to say person equals person. Maybe I'll name the column differently than the vector name. I'll call the column name the person equals person. So person is the vector we created on line 3, right? Then we say the age just to make it different. You can make it the same, use the same word, but just for the sake of pedagogy, teaching how to do this, I'll just make the column name different from the vector name. Okay, and then we'll say, I'll call it the_df for the data frame, hit it, that is run it, and then I come down here and I have the_df. Okay, yeah, I have a 3-row and 3-column data frame. Right, the 3 rows, the rows are the people and their information, their name, age, and location, and then the columns are the types of information about each of those people, their name, age, and location, like that. Good, so you can use vectors to create columns in data frames like we just did. And if we wanted to, we can make this a little bit visually easier to see on the human reading this code by doing something like that, where you put kind of each column on its own row of the code. So 7, 8, and 9 are on kind of separate columns in the data frame there. It doesn't matter. R doesn't care that it's all in the same line like I had it before. But okay, let's keep rolling. Let's go back here. Students create several data frames and put them into a list. Okay, so we have one data frame called the df. Should we create a second one? Let's create a second one called the, I'll just call it whatever, df2, just whatever. In fact, let's use a Tibble here. So in order to use a Tibble, I need to import tidyverse up there on line 1. See that tidyverse, I need to run that line. And when you run it, it'll just simply print out a message saying, I'm bringing in these packages. There's 9 packages there that it brings in. Cool, one of which is Tibble right there, that one. Okay, so let's create a little Tibble for fun this time. We can use it as we would any other data frame as the data.frame. So let's make a second one. Let's say whatever, it doesn't matter here, how it's whatever, computer is a column name. I'm at a little vector. I'm going to say Mac, I'm going to say Dell, and I'm going to say, I don't know, Red Hat. That's a server system or whatever. It doesn't have to be the same. Actually, I'll only do 2. It doesn't have to be the same number of rows as the previous data frame. So let's say computer, and let's say owner equals C for vector. The owner is Sarah of that one. and the owner of the Dell is Mike. So if we run that line of code, line 11, it copied it down here in the console in the bottom part of my screen. Look at df2. Yep, we have a 2x2 data frame. It's actually a tibble to be quite exact. And now we can say, okay, that's cool, list. Let's have you. We want to use the list function, and we can put in the data frame as well as df2. And it, by default, it just gives you a number if you don't give it a name. If we wanted to, we can name these elements. The bottom part of my screen, you can see it says square bracket 1, square bracket. And then here's the actual data frame that came in as the first one, which is the df, which we defined on lines 7 through 9 there. But if we wanted to name it, we could name it. We could say something like, I don't know, whatever you want to say, the first data frame in quotes, equal sign, and then the second one we could call whatever. What should we call it? The second one. We run it, we get those names as the elements of those lists, and we get the same data frames in there. And this one's a tibble. It says so right there, tibble. This one's a data frame. A list doesn't care. A list can hold whatever. Okay. So anyway, the list object there, the list function does that. We can say our list is the name of that variable that's holding the list. It saved it to a variable called our list. So if we typed in our list at the bottom part of my screen, we have our list. Let me go ahead and, there it is, our list. If you want to pause the video and make sure you get something like that working, go for it. Let me expose all the code that does those things. From my lines 3 to 13, I've done everything we've talked about so far in the video. Okay, when you're ready to move on, keep moving on. Let's move. Students iterate over the list with the for loop and print each data frame to the console. Okay, our old friend, the for loop. Maybe it's a new friend for you. Let's take a look. If we go for parentheses, I'm going to say current underscore df outside the parentheses, or excuse me, in the name of the list, the name of the variable that holds the list is, what is it? Line 13, our list, right there. Curly braces, and then we just print the current data frame. Remember how to do function or for loops? We saw this in a previous video. Let's just run it, bang, and let me expose it down here a bit. So, yeah, there it did. It printed them out. Now, the result is not really much better than just simply saying, hey, give me the whole thing by typing in the name of the list, which is our list that we define in 13, but just to practice the idea of a for loop. I mean, to make this clear, you could say, we could print something out and say, here's the current data frame colon. I think I need to put a new line break like that. Let's see if I do. Yeah, that \n there on my line 16 is a new line break. Didn't actually do that. Did print it down there. Yeah, we don't get too worried about that. That's not the important thing here. The important thing is the for loop. There we go. Okay. Anyway, yeah, so it's printing out. It's running it twice. It goes through here and runs these two lines twice because there are two elements in our list, both of which are data frames. Good. Students iterate over the list and then iterate over the row of each data frame and print each row. Okay, let's try that. Let's modify a little bit of code. Actually, let's leave that there for good measure. And I'll modify this a bit. So when we're looking at, oops, I erased our closing curly brace, which we didn't want to do. I erased what's on line 23, which we did not want to do. So we need to do a for loop over each row in each data frame. So let's go current row in current data frame. Then we're going to print out, we need to grab the current data frame, and we need to index into the current row. The way you index into a data frame is the first number you give is the row, and the second number you give is the column. So I'm going to just go down column 1 and print out each row in column 1. Let's stop here for a second. Let's look at this. Line 20 says for current DF in our list. Our list comes from what we called it up above, right there in 13. We call it our list. This current DF is simply a variable that we're going to use within the body of the for loop. Okay? And we use it right there on 21, right below it. So we're looking at, when we go through each element of the list, we're looking at a data frame at each one. And when we're looking at the current data frame, we want to go through each row. So, it might be a little bit easier just to see what's happening here if I don't actually use the word current twice. It's kind of a little bit confusing there. If I just say the row in current DF. So we're looking at the current DF, like the first one on the first iteration through the list. Let's loop over all the rows in that DF, that data frame. So we're going to index into the current DF at that current row, and then, I can see this is going to fail. Let me double check this is going to fail. Yeah, it did fail. I can see that was going to fail. I wonder if let me just answer a question in my mind that I have and see if I can. Okay. Yeah, so what I'm doing here, let me just kind of regroup here. I didn't actually ask for an index. I asked for the whole row. And so you can see here that the first row of the first data frame is printed out. Bobby, Louisa, and Luke. If we look at our list, it's actually printing out columns now. Let me revise what I said. It's printing out columns. Bobby, Louisa, Luke is what it printed out first, right there. And then it printed out the age, 23, 34, 45. That's what got printed right there. Let me zoom up, open this up a little bit. And then it printed the 3 locations, Provo, Rancho Cucamonga, Manhattan, right there. And then once it was done with that data frame, it jumped down to the second data frame in the list and printed out Mac and Dell, and then Sarah and Mike. Now, if we wanted to actually print out the rows rather than the columns like that, the way I'd probably approach this would be to actually loop over indexes. And so I would say 1 to the number of rows in the current data frame. That n row function right there on 21 is a function that takes in a data frame. I think you can take in matrices as well and other things. And then it gives you the number of rows that it has. And so we're going to say, hey, I want you to start at 1, and I want you to go all the way down to the number of rows in the current data frame. So go 1, 2, 3 on the first one, but on the second data frame, you're going to go 1, 2, because there's only 2 things that we put into the second data frame. And then once you're in there, we're going to have you go to the current data frame, and we're having you index into I, and then let's just start with the current, the first column there. And so what do we see here? We see, okay, let's see. Let me make a little bit of space so I can understand what I'm looking at exactly down there. Take a look. Me, Bobby, Louisa, Luke, and computer and Mac there. Anyway, that's how you can loop over elements of a list, and you can, if each of the elements in that list can be looped over in a for loop, you could do so within the for loop. This is called a nested for loop. Okay, so there you go. Those are the data structures that we'll see most, especially the Tibble/data frame. These 2 right here are the ones that we'll see most in this class. Anyway, again, I'll leave a link to this lesson plan in the description of this video. So there you have it. Thanks for joining. See you next time.